So we're looking at parallel lines, perpendicular lines. Those are familiar, I think. But then also like these transversals, I think that'll be the new stuff. So first I want to talk about a plane. In math class, like an example of a plane here in the room mathematically would be the floor. Yep. So a plane is just going to be a flat surface that's supposed to go on for forever. So like an example would be like a wall or a floor. Those aren't infinite, but you kind of get the idea. It's a big flat surface. So it's an infinite flat surface. And make that a little bit thicker, and we'll say like example, like a wall or a floor. Now those don't go on forever, they're not infinite, but at least you get kind of the idea. It's this big flat object, big flat space. Like a landing strip for an airplane would probably be a better one, something like that. So we have that. Now parallel lines are going to be two lines like what are pictured below. They officially never
meet.
So they never end because they're lines, good call, but they also should never cross, they should never meet. So they never meet. So even though like lines go on for forever, parallel lines will go on for forever, but they'll never cross each other. They'll never touch, they'll never meet. So fair enough for that? Make my erasers smaller and get rid of those. Okay, so parallel lines, the examples down below. And they have an abbreviation for those. The abbreviation, maybe let's label these. So I'm going to put a couple dots on the top one. We'll call it A and B. Put a couple dots on the second one. Call it C and D, I heard first. Now, if we wanted to say those are parallel, they do AB. If we want to say the line AB, what do I put above AB?
Line.
With arrows, without arrows?
Arrow. With arrows.
Because it goes forever in both directions. You put arrows pointing in both directions. Now to say it's parallel, they just do two vertical lines side by side, like that. So line AB is parallel to line CD. So we do the CD with the line with the double arrows above it. Questions? We okay on those? Feeling comfortable enough?
Yep.
A transversal is going to be a line that crosses two or more other lines. Typically, the way we see transversals, though, is going to be like this. You'll have parallel lines, then you'll have a line that crosses it. Technically, these don't have to be parallel, but what's that?
Like a street.
Kind of like a street. Street crosses. Sure. So I'm going to say it's a transversal. I'm maybe just going to point and say that thing right there. Can I get away with that?
Yep.
Cool. So the transversal is going to be like that line. It crosses a couple other lines. That's not a real important part of the notes. But what is important is these angles. I'm going to go through a number of the angles. I'd encourage you to number them the same. So that angle there I'm going to call 1, the upper left. The upper right I'm going to call 2. And then I'm going to go right below that line and say I have 3 and 4. And then kind of continuing the same pattern down below, I have 5 and 6 and 7 and 8. So if we have a transversal that crosses a pair of parallel lines, we get 8 different angles in there. We okay so far?
Yeah.
Now they have groups of angles that are going to be congruent. Congruent means angles are
Equal.
Nice. So congruent is like the equal word for angles. If two angles are the same, they're congruent technically. And they have names for pairs of angles that are congruent. So if we just try to dissect this first name, we have alternate interior angles. So interior angles mean it's going to be on the inside. So of these 8 angles, which of those 8 would you probably call interior?
3, 4, 5, 6.
Yep. Did you go 3, 4, 5, 6? Those are the inside ones?
Yeah.
Does that logically make sense?
Yep.
So alternate interior angles have to be one of these 4. Okay, now what's going to be the alternate angle with 3? Is it 4, 5, or 6?
6. 1, 2.
Good. If 6 makes sense, well, 1, we said alternate interior angles. You could say they are congruent. In other words, they're going to be the same. If you want to put that little symbol for congruent parentheses, maybe that's the symbol for congruent. So you could do what are the pairs 2 ways. One, you could say, well, 3, what's an interior angle that has the same measure as 3? And it has to be 6, right? But otherwise, you're saying what angle on the inside is on the alternate side of that transversal, the opposite side of that line. So if you wanted to write examples, you could say angle 3 and angle 6. So those two are going to be alternate interior angles. The other pair of alternate interior angles would be
4 and 5.
nice, angle 4 and angle 5. Because angle 4 and 5, they both have the same measure, and they're both on the inside, and they're both kind of diagonally across that transversal. We okay for alternate interior angles?
Oh, yeah.
Keeping the names straight. For me, if I can think of them in a way that makes sense to me, I'm way more likely to remember it. Okay, so corresponding angles. Where do you sometimes hear the word correspondent?
Together.
Well, I don't,
Like together-ish.
well, maybe all those two. I think of it this way. I think of like a war correspondent. That if you have someone that's, so say in the Ukraine, and they're reporting back to Fox News or to NBC or something like that, a war correspondent is trying to make it be, they're trying to explain to us what's going on there. And if they're good, it's kind of like we're there. We can kind of picture what's going on from what they're reporting. Yes? So I'm going to try to use the argument that corresponding angles are going to be two angles that are in the same place. Kind of like a war correspondent's kind of like making it like we're in that same place. So, okay. I'm trying here. Okay, so corresponding angles. I want to first say that they are congruent. And so an example. And maybe my example will crash and burn. Maybe it'll be okay. But so say angle 2. Angle 2 is kind of in the upper right. Agreed? What other angle could you say is also in kind of the upper right?
7.
7 is lower left, though. 6.
Oh.
Could I convince you that if you look at just the top half, so if you just look at the top half, 2 is in kind of the upper right of this junction. Do you agree angle 6 is also in the upper right of now this like 4 corners? So upper right. So angles 2 and 6 are going to be corresponding angles. So angle 2 and angle 6. If I were to pick another example, you could say angle 1 and 5. 1 and 5 are both upper left, kind of for that 4 corners.
4 and 8.
So example 2, maybe you could say angle 1 and 5. Or other people are saying 4 and 8 would work. 3 and 7 would work. But you kind of look at where are they kind of in that 4 corners. 4's in the bottom right. 8's also in the bottom right. And they also are the same number of degrees. They're congruent with each other. How are we doing? Okay on those? Vertical. Ready for vertical angles? I look at vertical angles this way. If I take that V in vertical angles and put a line there, I just made a
Down arrow.
down arrow, right? In the arrow? Oh, did I zoom in too much? So you could take that V in vertical and make it into an arrow. Agreed?
Yeah.
So now if we were to take that, well, maybe I should quick write in vertical angles. They are congruent. Kind of the pattern with the others. If you could take, say, angle 6. I'm just kind of picking for an example. We'll say angle 6. And if I have that 6, do you agree I could take this here, and if I turn that into an angle, or an arrow, it points at angle.
4. Oh, 7.
Do you agree this here points at angle 7?
Sorry. Yeah.
So for me, I keep it straight. Vertical angles, I try to think like turn it into an arrow. It's going to be angle 6 and angle 7. Because kind of the arrow of that joint, that thing right there, kind of points at angle 7. Yes?
I don't see it. I see it. Can you say
So
that again?
I'm trying to take this 6, and that kind of looks like a V-ish. And just like you can take the V and kind of pretend it's like an arrow, it points there at the 7.
Oh, I get it.
If that's totally not working, maybe you could just say, instead, let me get rid of my V's here. And you could say something like diagonal,
Wouldn't 2v1?
diagonal across
2, 3.
the junction.
Oh, that's what I meant. Sorry.
So yeah, let's pick a different pair. So I heard angle 2, so example, angle 2. Okay, angle 2 and 3, do you agree they're kind of diagonal across the junction? This angle points at angle 3.
Could you do what could you do? 1 and 4?
Yep, or you could do example, angle 1 and angle 4, if that would work. Because angle 1 would be a wider angle, but still it's kind of pointing over at angle 4, agreed?
Yeah.
Something like that. For those three, feel like you have a fighting chance?
Possibly.
Yeah.
Yeah. Sure.
Then I failed as a teacher. Push comes to shove, you study them. But those are names that aren't going to go away. You'll see those coming back hardcore when you get to geometry class. Okay, if we move on from there, though, congruent segments. Congruent is kind of the math word for equals, like the angles are the same angle, same number of degrees. If you have congruent segments, a wise person would guess congruent segments are...
Equal parts.
Yep, it's a segment. A segment was kind of like a line that stops, right? A segment was something like this here from yesterday's notes. So if we have congruent segments, you could say two segments that are the same length. So two segments, two parts of a line that are the same length. Or I suppose they don't have to be parallel, but might be easiest to draw if you did something like that there. So congruent segments are two things that are the same length. And so we can use that to do midpoint. If I were to, for a midpoint, say, so I'm going to draw a segment kind of down here at the bottom. And maybe let's label this, I don't know, P and Q, just for picking letters. The midpoint is going to be where on that segment? Nice, halfway in the middle. Do you agree right here is going to be the midpoint?
Yeah.
Yes.
At least to the limits of my drawing ability. So my first bullet point, I'm going to say it's the middle of a segment. Because we couldn't say the middle of a line, because a line goes on for forever. But you could say the middle of a segment. And kind of the more official definition is a point that divides a segment into two congruent segments. And if you want to review that whole, congruent just means equal. So it's going to be a point that divides a segment into two congruent segments. So if we were to maybe make that a M, you could say PM, the segment, is congruent to MQ. Like that.
Don't turn it off.
So a segment bisector is a line through the midpoint of a segment. So a line through the midpoint of a segment. So if we were to go with something like what we did before, I'm just going to put in a segment, maybe call it A and
C. D. 18.
I
No,
guess
C.
I heard B
C.
first, but it's not real creative, but that's what I was going to do, so I'm not ripping on whoever said B. Okay, this point in the middle, I'm going to write an M by it, but I'm going to put it off on the sides. That's supposed to be my midpoint. And if we're trying to do a segment bisector, now we just do a line through that midpoint. It could be a vertical line, so it could be a 90-degree angle. It could kind of be on some angle thing like I have or something like that. So if we were to jump down to perpendicular lines are going to be two lines that cross with what angle?
Diagonal. Horizontal.
So this angle here is less than 90. It's acute, right?
Yes.
This angle here is bigger than 90. It's obtuse. If we wanted to have those lines be perpendicular, the segment line be perpendicular, it'd have to be a 90-degree angle, right?
Yes.
So perpendicular symbol is this thing here. It's supposed to be a vertical and a horizontal line touching. And basically, the angle equals 90 degrees. So if you have perpendicular lines, perpendicular segments, I guess that's what I was going to write down below. Create. So these things say create, bless you, a right or 90-degree angle. So perpendicular lines, perpendicular rays, perpendicular segments, or a combination of them, they'll meet and they'll have a right angle. So we'll draw that quick in this very last thing, but if you have a perpendicular bisector, we need to do two parts. Perpendicular means we need to have a 90-degree angle, right?
Yeah.
So then we could say it's going to be a line that crosses a segment. I'm going to leave that second blank empty for now, and at the very end say and forms a 90-degree angle. So that's our period. That's our perpendicular part. If it's a bisector, it's going to be a line that crosses a segment at its
Point.
what point?
The A. First. Nice job.
So midpoint.
Get in there. So good.
Because a dissect just means to cut something. A bisector means you cut it into two parts, to bisect, two equal parts. So if we wanted to do this here, I need two letters.
A, D, C, and 9.
Z and A.
Yeah.
Z and A, I like that.
I like
So
that.
Z and A. Put the line through the Z if you want, I'm used to that. In the very middle, we put an M for midpoint. Then I need two other letters. I'm going to try to do D and C.
Jen had that ready to go.
Yeah.
D and C. And if we want to put in a symbol to show it's a 90-degree angle, remember that from earlier notes?
This square little thing in
Yep.
the corner.
Put a little square in there, something like that to try to show it's a 90-degree angle. But that line DC then is going to be the perpendicular bisector of segment ZA. And that is it. So we got a bunch of learning targets in there, a bunch of learning targets. And
There's more.
assignment at the bottom.